Hi all. Uh, Today we see one of the fundamental concept behind ChatGPT. In the last video, we explained that there are basically two components in building a ChatGPT. One is generative pre-training, and the way how the architecture is trained. The other one is a special neural network architecture called transformer neural network architectures. So in this video, we see what are the concepts we needed to build or we needed to set up a generative pre-training. Maybe in the next video, we'll see what are the papers or what are the fundamental concepts behind the transformer neural architectures. So this generative pre-training to understand before we introduce some 2 to 3 papers. What is a fundamental concept about this pre-training? How does this helps in building a chat GPT effectively for various tasks? So on the first fundamental concept behind this pre-training is to make understand what does mean by statistical machine translations. This statistical machine translation is like kind of a special setup of neural network architecture for especially built for language models. Um, and this is based on two mechanisms. One is recurrent neural network, and the other one is an encoder decoder mechanism. So what this paper says is this paper proposed a neural network architecture which will be referred to as an encoder decoder mechanism, and this has basically a two recurrent neural networks. One is an encoder and the other one is a decoder. The encoder maps a variable length of sequence of words into a fixed length vector, and later the decoder takes that fixed length vector as an input along with the other usual input. It's basically a RNN to predict the target sequence. So these two networks, the encoder and decoder based on RNN, are trained jointly to maximize the log likelihood estimate of the target sequence given as a source sequence. So this architecture can be clearly explained in this figure, where this is an encoder mechanism and this is a decoder mechanism. This is an RNN where it takes a sequence of input x1 to xt, and the final hidden state output would be given further as an input to the decoder mechanism. This decoder mechanism is another RNN. It predicts a sequence of output based on this equations. So this as similar to a conventional RNN, it takes an input and hidden state along with an out along with the C, which is referred to as a summary of the input sequence. It means that the last hidden state of the encoder mechanisms. So this encoder decoder mechanism is jointly trained on the conditional likelihood log likelihood estimation, which is based on these equations. And this is based on the output model of the decoder mechanism, which takes the input and the hidden state and the collective informations from the encoder mechanisms. So both encoder and decoder will have a variable length sequence, but the encoder mechanism will put the variable sequence into a fixed constant vector representations. And that is a key fundamental concept behind this encoder decoder mechanism. And since this output decoder is fundamentally a differentiable one, they have used a gradient based algorithm to fit these model parameters both in encoder and decoder jointly. So this is what is called a sequence to sequence modeling architecture, which was very popularly utilized before introducing the chat GPT architecture. So what does this paper says is, to be summarized, it introduced a neural network architecture for especially for a language modeling called statistical machine translation or neural machine translation, which has encoder decoder mechanism based on RNN. Later we will be seeing that how this RNN has a limitations, and that is been addressed by an attention mechanism that gives the transformer architecture. The second paper is related to a paper from Andrew and Hugh from Google. What does this paper says is they have introduced two approaches. We know that labeling or annotating text data is highly cumbersome, but we have a large abundant of text data which is unlabeled. So this paper try to exploit those unlabeled text to improve the sequence to sequence modeling that I introduced earlier. So they says that simple pre-training. What does mean by pre-training, that will be coming here, but they says that there will be a unsupervised pre-training before going to supervised training. Will give you a more stabilization and more better generalizations during the training of the sequence to sequence modeling. How does they do this type of pre-training? What does mean by pre-training is they have this unlabeled data. They formulate something called a concept called language modeling task. So where what does this my language modeling task is, they try to use the previous, in a sequence the previous input would be given as a previous the previous value or previous label will be given as an input, and the next the current will be predicted as an output. So this doesn't require any annotations. So this will be itself considered to be kind of a logical structure in while making an objective. So those pre-training things can be done using this sequence concepts, and that does that the terminology is called as language modeling, that sequence autoencoder. So I just read here, maybe that the way I am explaining might be not that quite efficient enough. So they says that pre-training can significantly stabilize the training of the LSTM, because the LSTM has some limitation to make a long range dependency. So what they use is then the next step prediction. The recurrent language model is the concept they introduce as an unsupervised method. So what does this mean is it reads a long sequence and into a single vector that we introduced earlier. This will be used to reconstruct the original sequence. The weights obtained from these pre-training methods. There are two pre-training methods that we will see here. What does mean by is it uses a recurrent neural network as an encoder to read an input sequence into a hidden state, which is then input into a decoder recurrent neural net that produce output. So that's the same thing like sequence to sequence modeling. So the same, what does here they does is they replace the output sequence into an input sequence. So they have some kind of a structure. This has been encoded into a hidden state. Then that previous one will be predicting the output one. So it doesn't require a special annotations. So these settings, they what they say is like an unsupervised pre-training steps. And once the other model that they introduced two model. One is this kind of an sequence autoencoder. Another one is just simply removing this and the encoder mechanism, and just put only this previous input to the output and previous input to this present output and previous input to the present output. So those setup is said to be called as a recurrent language model as a pre-training method for the LSTMs. Once this setup is done and it is a large corpus of data which doesn't have annotations, only they have some kind of a relation like previous word will be connected to the present word. Those connections has been, and that logic has been utilized as a kind of an objective, and that is been